I think we're live. Okay, so we are live, and after like 2 weeks, maybe. Yep, it's good to be back. And let me just set up the stream view. All right. This thing, this size is okay. Yep. All good. One more. I think it's okay. One more for add. It's not a break time. Maybe this. Okay, so we have our webcam. No, just look at this beauty. I hope she is visible. Okay. Done. Let me check the stream. Okay. All done. So let's jump and set up our coding environment. We were coding from atcoder, right? We were solving problems from atcoder. Okay, I'm logged in because of the recent contest or not. Yep. I was not able to solve this fourth question on time by the way. So there is that. Which stream is this? 34. Let me check. Right. Stream settings 34. Okay, we are back. Copy and paste. Just Remove all this. We are all set. And I think we have solved till what? Q. What question is Q? Oh, it is that question, right? That segmentary question, right? Where instead of going for n, uh, we chose h. We stored h, and like in a particular segment we queried for the value, maximum value or something like that. Okay, I remember. You can see my submission as well. Where can I see it? Okay. Yep. It is that only. Maximum segmentary. Okay, yeah. For this height we are adding the whatever it was plus the query, whatever flower we get from the query, and then we are updating it. I need to solve it again. Okay, we'll be solving it again anyway. So yeah, let's go to walk, which is a graph problem, and let me open what was the whiteboard. Okay, let me open the whiteboard. Okay, it was this side. Where is the where are my other row? Okay, yep, this is the, which question is this? This is for flowers. Now we will solve. Why is it stuttering so much? Oh, one second. I hope it is not stuttering. Okay. Actually the charger was not on, so that is why. And what PQR? We are wait, why? R. Okay. I'm doing this after so many days now, that is why my writing is like this. Okay, so problem R, walk. Let me put on my specs. Just a second. Sorry, I went to get some snacks. So that is why. Okay. I think we are ready. Okay, angle and all is correct. Okay, so there is a simple directed graph with n vertices, 1 to n, and for each I and j, we are given an integer aij, directed edge. Okay, so the thing is, the constraints are for k it is 10 to the power 18. So we need to, we cannot run a loop simply. I was thinking of like doing maybe of path of length 1, then building upon that by like somehow making use of path length 1 into path length 2 and like that. So it seems like that will not work, and we have to do something else here. Okay, so n is from 1 to 50 only. Okay, and the path length can be, am I mute? No, I don't. And the path length can be as huge as k, which is 10 to the power 18. So surely we are we will be moving in cycles. Okay, so if instead of moving in those cycles, if we can somehow calculate okay, Sorry. Reacted paths of length 2, 1, 2, 2, 4, 2, 3. Okay. Okay. Suppose we have a node like this. Okay. Suppose we have a node like this, and we want to get the number of paths for k is equal to maybe 4. So what is the length 4? What are the length 4 paths? Okay, starting from 1, we have this, then this, and then hopping to this, and then this. So we have 1, 2, 3, 4. Okay, first path. Second path, starting from 2, we have 2, 3, 4, and 5. Hmm. Starting from 3, we have 3, 4, 5 and 2. And starting from 4, we have 4, 5, 2, 3. And starting from 5, we have 2, 3 and then 4. So what can we see here? The thing is, if the size of the cycle is greater than or equal to k, then it is possible to add what, that many, like the number of edges in that cycle, paths to it. Okay, but if it is not, suppose we want k is equal to, let's say 5, then this cycle is of size 4 only. So the only viable option that we have is this one. Okay, so all the cycles which are of all the cycles which has size less than k should not be able to contribute. No, I think there should be. For example, suppose we had something like this, right? Then we can go 2, 3. For example, from here 4, 5, 2, 3, 6, something like this. So sometimes it is possible. this case, oh, this problem is not easy to uh, like this problem is not easy to solve, and also not easy to be able to like mm, visualize. Maybe if you maybe you can visualize, but building a solution on top of that is not easy. That is one more thing that we can think of is that connected components, and like we have a strongly connected component, right? So a component from which it is possible to reach a node from other node. For example, this 1 2, so it is possible to reach 2 from 1, and it is also possible to reach 1 from 2. So it is a strongly connected component. But here 3 this is a connected component but not a strongly connected component. So we can reach 3 from 1 and 2, and number of ways to reach 3, so that the path length is what 3 is. We start from 1 2 3, or maybe 1 2 1, not from 1, we can start from 1 2 1 2 1 2 1 2, like this. Okay, you can then start from 2. From 2 it is possible to go 2 1 2 1, okay, 3 size, and it's also possible to go 2 1 2 3. So 2 valid options we have for length 3. In a strongly connected component, how many path, how many ways, or how many paths will be contributed by it, through it, maybe. Just can't think of any solution. It's out of my scope. See? Can't even think of a solution right now. Maybe this find the number of integers between n and k satisfying the following condition. Oh my god. Why do you have a k which is this? Like how do you even check from the back end? Maybe okay. So yeah, the way we solve it similarly. But verifying it is okay, maybe there is a proof of it. Sum of digits in base 10 is a multiple of d. Sum of digits in a base 10 is a multiple of d. Okay. सॉरी सॉरी, घर से फ़ोन आ गया था इसलिए। ओके भाई, ये वाला सवाल तो क्या बताऊँ। फाइंड द नंबर ऑफ इंटीजर्स बिटवीन 1 and k inclusive satisfying the following condition: module 10 to the power 9 plus 7, the sum of the digits is base 10 is multiple of d. Base 10, sum of digits in base 10 is multiple of d. We need to find all the numbers less than equal to k and greater than equal to 1 such that the permutation of certain numbers is always the sum of them. So basically, let's see, I cannot solve this question, so let's say pending. Sorry. Pending. Okay. So the next question is RS. What is it? S digit sum. Digit sum. Okay. So suppose we have a number 30 and 4. We have a test case 30 and 4. So what numbers are there? 1, 2. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 20, 23, 24, 25, 26, 27, 28, 29, 29, 30. Okay, so among these I can see this and this as like as a multiple of what? As a multiple of 4, right? And if we double it, maybe, so we will have 26 and also 8. So if we can find, oh no, I was thinking of maybe doing like cursive or, but it will not work like that because k is very huge, right? So we cannot do it like this. And the thing is, looking at the constraint, we can see that k can be as big as what? 10 to the power 1 0. This, right? 4 zeros. So 10 to the power 4. So most probably this is log k square. Okay, or we have d as well, so maybe something like this, log k, or maybe d log k or something like this. So we need to think of a algo in this direction. Okay, so how do we get a log k? So instead of going for 30, and input are integers, so how are we supposed to take this input? Yeah, it doesn't make any sense, bro. 3, 4, 5, 6, 7, 8, 9, 10, 11. How can we take integer input in this? Modulo 10 to the power 9 plus 7. Okay. I guess the sum is less than equal to 100. This it's not a simple solution, I think. Again, none of the questions after the like p maybe are not easy. Yeah, you see this string, whenever there is a string I just cannot solve it. Number of permutations such that this satisfies. Bro. Grouping maybe. It does some number of groups. Okay. Okay, so it can be negative as well. 16 cross 16, so 256. And then we will start. We will have a loop ij, and we will choose to put them in one group or another. The number of groups is not mentioned, so it is possible to separate them into 16 different groups, maybe, and different groups. So what we can do is we can start from all the rabbits in different groups and then try to combine them. Okay, and in doing so we can find what is the maximum score that we get, right? So what I am thinking of is, this is U. Grouping. Okay, so what I am thinking of is, we are given n rabbits, right? For example, here we are given this. Okay, so initially we will have this rabbits in different groups. Okay, we have 3 different groups, so we can try to combine them. So it is 1, it is 2, it is 3. Okay, so if we combine 1 and 2, then the score we gain will be what, 10. We will get 10 score. Okay, we will get 10 score. And now we have the option of combining it or not. So if we combine 3 with this, then then we will get, if we combine it, then if we combine it now, Then we will have 3 1. Okay, so it will be double that. One second. Okay, so we have 10 only. And if we combine them, then we'll have 3 1, which is 20, and 3 2, which is minus 100. So it will be overall minus 80 plus 10, so it will be minus 70. So if we combine all of them, so it will be minus 70, and it is not the optimal answer. So instead of combining 1 with 2, we can combine 1 with 3 and leave 2 here. So combining 1 and 3 will give us 20. And if we combine again with 2, so it will give us 3 2 1, same, minus 70. So it is best to leave it here so that we have the maximum score. Okay, but in this case, it is not sequential. Okay, so more like a permutation, and since it is 16, we cannot just do it. No, that will not work. Because the maximum permutation limit is 8 factorial, I think, or maybe 10 factorial, because after which it becomes, the value becomes very large. So it is not possible. We can also see the values here, 10 factorial. See, it is already at the limit. So yes, it is not possible for us to enumerate all the combination and then try to do it. That will not work. Recursion also, it will not work. Recursion also will not work. It looks like we'll not be able to solve any question today. Subtree, please. Okay. If there is a black, then it will be in CL. If we start painting one as black, then it will either continue or not. It will not be like so every vertex has two options. Either start a new black vertex or continue from the last. Okay. Feel like I can solve this, but I also feel like I cannot. This needs to be studied. We go to interval, Okay, what is the maximum possible score? Answer cannot be zero and negative. Again, a difference array, and if we find that there are overlapping positions, and if we find that we can have a positive value out of that, then we will take it. But then again, it looks simple, but I don't think it is. What is this tower problem? Holy shit, it's a 3D knapsack. The only solvable question is intervals, but I don't think it is, because of just how those other problems are. Man, wasn't able to solve a single problem today. Wow. A great start to the new year, huh? So what then? Should we end the stream? I guess so. We'll need to look into the graph problem and tree problem, and also this interval. I'll look in the editor tomorrow, most probably. Editorial, sorry, not editor. And we'll solve it then. And yep. Also, we will start solving graph problems. And some, you know. Okay, so what we can do is we will start solving graph problems, and on weekends we'll do revision of DP. How about it? That will work. So weekends we will have we will stream like uh, maybe okay, Saturday 5:30 to 7 it is contest, atcoder contest, so that is not possible. In evening maybe we can do it in morning. Okay, but Friday night I play games, so it will not also work. uh, Maybe afternoon 2 to 4 or something we'll do DP revision, or revision of any content that we have been practicing, something like that. Okay, yep, so that is the plan. And okay, yeah, we were not able to solve any problems today, but maybe tomorrow we will solve 2 to 3 problems. That is why we were not able to solve any today. Who knows? Tomorrow will be our day. Okay, so yeah, I think that's it for today's stream, and I hope you have a good night, very good night, and also a very happy new year to all of you. And bye bye, peace.